All right, let's dive straight into your GCSE computer science revision. Today, we're looking at something that really separates the pros from the beginners: how to produce robust programs. This comes straight out of the OCR J277 specification. And trust me, by the end of this, you'll know exactly how to build unbreakable armor for your code.
Oh, we've all been there, right? You spend hours, maybe even days, getting a piece of code just right. It works perfectly for you. But then, the very second someone else gets their hands on it, boom, it completely falls apart. It's super frustrating, but it's also a classic programming challenge that your exam will definitely test you on. So how do we stop this from happening? Well, we're going to build what I like to call code armor. First, we'll figure out why programs break in the first place. Then we'll build our first line of defense. After that, we'll look at controlling who can even use the program, learn the secrets to writing code that's easy to fix later, and finally, we'll wrap it all up with a quick exam checklist to make sure it all sticks.
Okay, Section 1. Why do programs break? This all comes down to something called defensive design. The big idea here is that you need to stop thinking like a programmer who knows exactly how the code is supposed to be used and start thinking like a regular user who will do literally everything you don't expect them to.
And there it is, the #1 reason programs fail: unexpected input. You know, sometimes it's an honest mistake, like a user typing the word 20 when you asked for the number 20. Other times, it could be something more deliberate, like someone trying to break your program on purpose. Either way, your code has to be ready for anything.
This leads us right to the core strategy you need to know for your exam: defensive design. Think about it like this. It's not about trying to patch up holes in your armor after you've been attacked. It's about designing the armor to be so strong from the start that the attacks just bounce right off. You're anticipating the problems before they happen.
So, where do we start with this armor? Well, our first and honestly our most important tool is called input validation. This is basically the bouncer standing at the front door of your program.
So yeah, think of a bouncer at a club. Before any data gets into the main party, your program's logic, the validation process checks its ID. Hey, are you the right data type? Are you in the right range? Do you have the right format? If the data doesn't meet the rules on the list, it's not getting in. Simple as that.
Now, pay close attention here, because this is a direct quote from the OCR specification. It's not just a friendly suggestion, it's a requirement. It says your program must know how to handle invalid data. This is an examinable skill. Your code can't just cross its fingers and hope for the best. It needs a solid plan for when things go wrong.
And here's a perfect example of how you should test your validation. Let's say your program needs an age between 18 and 65. You don't just test it with a normal number like 35. You've got to test the edges, the boundary data, like 18 and 65. Why? Because that's where bugs love to hide. Then you have to hit it with invalid data, like a 100, which is outside the range, and erroneous data, like the word 10, which is the wrong data type. A really robust program will accept the good stuff and politely but firmly reject everything else.
Okay, so we're checking what data users are typing in, but what about who these users are in the first place? That brings us to our next layer of code armor: authentication.
Authentication is all about confirming who someone is. It's your program asking, who are you? And more importantly, can you prove it? This is absolutely essential if you want to protect any kind of sensitive information or special features inside your application.
Now, for your GCSE, you just need to understand a basic authentication system, like a good old username and password. It's a really simple 4-step process. First, the program asks for the username and password. Second, the user types them in. Third, the program checks what they typed against a stored, correct version. And fourth, if they match, access granted. If not, access denied. Easy, but so important.
Our final piece of armor isn't about blocking bad data or unwanted users. It's about something else. It's about making sure your code is easy to read for the most important person who will ever look at it, which is probably going to be you 6 months from now trying to figure out what you were thinking. This is called maintainability.
And here's the thing, a robust program isn't just one that doesn't crash. A truly robust program is one that a human, you or someone on your team, can easily understand, fix, and improve later on. Because let's be honest, if you can't understand your own code, it's just a ticking time bomb.
So the exam spec actually gives us 4 key things to focus on here. First, use meaningful names for your variables. Call it user age instead of just X. It makes your code practically read like a story. Second, add comments, but use them to explain why you did something tricky, not just to state the obvious. Third, indentation. Use it consistently. It's like paragraphs in an essay. It shows the structure of your code. And finally, use subprograms to break big problems into smaller, bite-sized pieces. Remember, these aren't just tips. These are things that will get you marks in the exam.
All right, let's wrap this all up. Time for a rapid-fire exam checklist. These are the absolute key things you need to remember about defensive design.
First up, the mindset. This is the foundation of everything. You have to assume that your users will find the most creative ways imaginable to try and break your program. Always plan for that.
Next, your weapon of choice, input validation. This is non-negotiable. It's your first line of defense. Never, ever trust user input. Always check it before you use it.
Third, the gatekeeper. That's authentication. It makes sure that only the right people get access to the right parts of your program.
And finally, the habit of a true professional, writing maintainable code. Clean, well-structured, and commented code isn't just about being neat. It's about building something that can actually last, be fixed, and be improved over time. It is a massive part of what makes a program robust.
So, as you go into your exam and as you write your next project, remember this stuff. It's not just about theory. It's about learning the real craft of building software that actually works in the real world. So the only question left is, how are you going to use these techniques to make your next program completely unbreakable?